Today we're going to talk about questioning. Today we're going to talk about being a kid detective. Today we're going to talk about uncovering, digging up what they understand and what they know. Thank you.
That's all the right answers.
Oh, I need that today. Take a look at Zoey. She has a problem. Okay? You do not have to do this by yourself. We're not going to make you work alone. We're not going to do starts. We just want you to talk about this problem and get a sense of what they're asking and what a good, reasonable answer would be. Okay? Can you do a visual? Oh, I see. Sorry. No, that's not visual. That's numbers. Yeah, we need a model. We need a picture. We need some sort of model that can show. So see, that's a bar model that's labeled with her numbers. So it shows that it comes in that she has 3 sets of yeah. So that's a tough one because kids are not used to. They're used to just really being algorithmic only, and we're pushing on them, and that's hard to do. Are you back? Okay, if you could tap your neighbor. So on my walk around this enormous group of math teachers, it's interesting. One of the things that got a little bit argumentative was that last sentence. And one of the things that we traditionally have never asked for is visual models. And the Common Core says, yeah, we want to see your thinking in a visual model. So we have to start practicing within our own classrooms how to get a visual model. I think this is an interesting problem to do a visual with. This is hard. So let me tell you the story about this problem. This is a 7th grade problem. It comes from, I believe, the South Dakota Common Core or Kentucky Common Core materials. And I found it because I was asked to do a demo in an 8th grade. And I don't really like 8th graders, so I was, I didn't even like my own kid when he was an 8th grader, so I was a little nervous about it because they do weird things, right? So I said, yeah, see, true. So I said, I'll only do it if I can do a fun problem and not teach anything algebraic because I'm not interested in getting their procedural fog. So I did this problem, and I showed up at the school, and the principal, I had sent it to the principal so he could make copies of it. And as I went over to the 8th grade, he goes, Fran, you know that problem about the balloons? Isn't that kind of too easy for the 8th graders? And I said, well, I don't think so. I go, tell me what you did. And he, along with 80% of the 8th graders in that class, did this.
Say those stats again.
Over 80% of the 8th graders and the principal solved it this way. And then said they were done. They didn't give it a second look. So, here's your job, and here's our theme for the day. This is a wrong answer. If you have it, don't feel bad. 80% of the 8th graders and the principal got the same answer. What kind of question, so this shows up everywhere. I'm walking around, I see it everywhere. I can't just say you're wrong. That gives them no information. So talk with the people at your table. What question would you ask if this showed up all over the place? Debbie's going to walk around with a microphone, or if I'm with a microphone near you. Raise your hand if you have a question that because your goal here is to direct the child back into thinking. Jerry and I spent all morning interviewing kids, and that's all we did all morning. Direct the child back into thinking. This was done with little or no thinking. Okay, question.
I would ask them what the numbers in their equation represent.
Okay, so you would say, what does the 15 stand for? What does the 24 stand for? And my favorite one, what does a 3.6 stand for? Everyone, what does a 3.6 stand for according to this kid? Balloons. So I said that to a kid. I said, 3.6 balloons? I have a couple problems with that. One is, how do you get 0.6 of a balloon?
You just stole my question.
Oh, okay, you go.
How do you have 6/10 of a balloon?
And I'll tell you what this 8th grader said. Well, you blow up part of it. Anybody? They're way over in the corner, Deb.
She's only right next to me, and it's Kathy.
Kathy with a K.
Kathy with K. If 24 is when he's been partway done blowing them up, how can we then only have 3 and a portion of a balloon?
Right.
Total.
And that was the thing that even the principal missed. That we were paying attention, and I'm making all kinds of noise, or is that you, Debbie?
I don't hear it.
How can you only have 3 and some balloons if Zoey blew up 24? It doesn't make sense. What else would you want to ask? Up here?
Am I still making noise?
No.
We had just tossed around the question, asking the students what the question was asking, and then look at your answer and see if your answer answers the question.
Okay.
And see if it makes sense. 'Cause
Right. And I have to tell you, these 8th graders were relentless in saying it did, and so I finally ended with, then that's a pretty drab middle school dance with 3.6 balloons. Not going to look very festive. And so it was funny how they went into this robotic, and we were sort of laughing about this idea that they don't even know that they've gone into robotic mode, and they don't even check themselves. Plus, they had kids around them who had the same answer. So if they did check with a neighbor, they were happy. Okay? But as a kid detective and a good question asker, I have to try to uncover to make sense of why they're stopping with 3.6. Okay? I can't let them stop with 3.6. Is your pencil going to go up? No. Okay. It might be me because I'm so loud here. Okay? So now let me show you what one little girl did. Okay? Take a look at this. Talk to your neighbor about what kind of sense making is going into that. So then she goes up and she says, okay, this is how I solved it. And she explains that she can deal with 30% much easier than she can deal with 15%. And she even tells us, I'll show you why when I check it. So she knows that 30% is double 15%. So she's going to double the 24 balloons that Zoey blew up. She knows she has to build up to 100%. That Zoey only blew up 15%. And that her middle school dance will be festive because there'll be a lot of balloons. Okay? So she goes through, oh, holy smokes. She goes through this whole thing and she does 30%, 30%, 30%, and she adds her 48s. This was fascinating. Because she said, you know, I know that there are 3 parts to 24, and there are 3 parts to 15. I didn't make her write this. I think a written explanation would have been good, but it was a short 15-minute thingy. So she said, so I'm going to take, since I want 10%, that's 2 parts of 15, so I'll take 2 parts of the 24, and that's 16 balloons. So what I get to do now is add a 16, and I have now 100%. You should have seen those kids who had answered 3.6. Because, you know, this was not a class, this was a class of kids who really have been kind of scoring high on measures like CST. They're really good number crunchers, and that's the evidence that we saw in that. Because I really appreciate when you say, you know, make sure they know what the question is asking. They knew what the question was asking. They just went after the numbers and crunch. That's what they do. Number crunchers, and this is where, and I know some of you are going, I don't want to hear this, stop it, stop it, stop it. When we're extra heavy on procedure, we get kids who don't even consider if their answer is even close to reasonable. Natalie's story was that she was not a very good number cruncher, which we heard about yesterday with our group yesterday, that as you're doing more problems like this, you're getting some kids entering in mathematics and getting it right that never did before, the Natalies, because they don't do it the traditional way, but they can make sense. So look what she does to check it. So she says, I'm not going to deal with 15%, because look what I did. I divided 100 by 15% to see how many there were of them, and there were 6.6666. I'm not gonna get, I can't deal with that. I can't. Because I can't figure out what 6.666 forever of 24 balloons is. I can't. I'm not gonna. That's why she did it the other way. Comments or questions? Well, how about this? What kind of question do you give for Natalie? She gets a question or two, too. What do you want to know about her? You don't just question the wrong answers. We've already taught our kids that's what teachers do. That if I ask you a question, you must be wrong, right? So what do you ask of a Natalie? Over here? Oh, it's a boom.
Well, the first question, and you already answered, I was, where did you get the 2/3? Okay. Because fractions, they're a nightmare. And the fact that she got a fraction, I'm just amazed.
Yeah. Makes sense to her. And that was included in her explanation, so we didn't even have to ask. But that's a cool question. What else would you want to ask Natalie? I want to get at that thinking. Debbie?
Well, I'm thinking it's not necessarily something I want to ask Natalie for Natalie's movement, although that's a good question too. But sometimes I'm thinking, Natalie's presenting and I have other children in the room I might want to move. So what do I want to ask Natalie? And maybe how did you come up with the 2/3 as an example of that? Or what's the relationship between the 30% and the 10% would be another way to think about how to get the 16. But to talk, maybe there's questions I ask Natalie because I'm hoping it helps the rest of the kiddos.
Absolutely. And so we made her go over the fraction thing twice because all the kids understood doubling the 15%. That wasn't a stretch. Soon as they showed 160, we started to get noises in the room like, oh, of course 3.6 is not right. That was a really fun day. And then I kept glaring at the principals like, you got 3.6? You thought this was an easy problem? Ha, ha, ha. Fifth grade teacher me. Ha, I gotcha. Okay? Other comments or questions on this? Okay, we're opening the door. Your job, you're a kid detective. You're a kid detective whether it's a right answer or a wrong answer. So let's keep going. So I have this question. Look at all these cool people. Some of these people I even appreciate. Okay, what do they all have in common? Talk to your neighbors. What do they all have in common? All right. What do they all have in common? Let's hear some adjectives that would make things that they share. Somebody said they're all really rich. Okay, what else?
Well known.
They're all well known. I shouldn't have repeated you. I'm sorry. What else?
I got one over here, Fran. They think outside the box.
Say it in the boom.
They think outside the box.
What else?
They're innovators.
Nice word.
Innovators.
Hey, Keith.
They all have some form of disability.
Oh, I didn't know that. Oh, she's making it up. And that may be a disability when you go to a public school. Okay? What else? They got a box? Yeah, they thought out of the box. Yeah.
I believe they didn't graduate from college.
People told them they couldn't do it.
Ah, and boy, did they do it.
They weren't afraid to make mistakes.
Ah, so a bunch of your comments describe thinkers. If you hung out with us yesterday, we talked about Captain Sully Sullenberger, which we won't talk about today, another big thinker. So you're describing people who think, and they're rich, and they did think outside the box, and they've done something kind of grand for the world. They're also all college dropouts. And I think the interesting thing there is that the system doesn't always appreciate thinkers or know how to hold thinkers. And the Common Core is shifting us in a direction where thinkers are going to be prized. You're already seeing evidence of it. You're seeing kids who may be on this list one day that are starting to say, hey, I thought about it this way. We had a little boy today named Adam who was brought to us because he probably wasn't super strong in mathematics. And he had to, at one point, because I got all gleeful on him, and said, oh my God, you're such a mathematician. He had to cover his face to collect himself because no one had told him that before.
Did she see me?
He didn't, let me not say that. He didn't think that of himself. And he had to really take a breath and sort of cover and regroup. So it was kind of nice. So here we go. So what are some of the opportunities that we're allowing for our kiddos in classrooms so that we grow great thinkers? That's what we're after. So you have this little page. Can you get out this little page? So this is called the depth of knowledge, or its nickname is the DOK, depth of knowledge. And if you look at the circle, go over to the top, level 1, and you notice there's a bunch of verbs that go up there. Level 1 goes with the idea of recall, of knowing a fact, being able to do it quickly. That's important. But that's not the only thing that thinkers do. So if you just browse and go down to 2, all of a sudden the verbs start to change a little. You go to 3, oh my gosh, you see things like revise, hypothesize, differentiate, investigate, compare. Those are thinking verbs. And then pop over to 4. Oh, those are top thinkers, top thinking verbs. So look at what we need to know about this. And we're going to deal more with this in your breakout groups as well, because we're going to talk about questioning and how you can ask those bigger questions. So this is the cover page to a Smarter Balance release. So those of us 3rd and up, 3rd through 11 will be taking this, or 3rd through 8 and 11 will be taking this in the spring, the first field test of it. And I want you to look right, where is it? Lost it. Oh, there it is, right there. DOK Level 2. So look at Level 2 and watch this. That's a question that the Smarter Balance people are going to assess our kids with, that they're saying is a depth of knowledge level 2. It's not an easy question. It's not a super hard one, but it's not easy. Okay? I don't know how much you took out. This is a 4th grade question. Oh, that's it. Okay? No, you don't have to solve it. But I want you to see, and yesterday I said, I really don't think we should move into the Common Core and think about this so our kids do well on this test. But this is a marker in their life of thinking. We're moving to the Common Core so more kids will think deeply. And that's what we're after. And the Common Core is going to really hammer that in a way CST could never.
Okay, so DOK levels. So as Fran mentioned, the DOK depth of knowledge is called out in, is going to be called out in the framework, certainly in the SBAC questions. Now, to take a look at the DOK levels, I think there's 3 lenses we kind of need to look at. We need to look at, it starts with the task. So quite often, if you look at SBAC, it will always identify a DOK level for the task. But you've probably, I think I said this to this group before. What happened when they gave the Smarter Balanced Assessment field test across the nation a year ago did so poorly on the DOK 3s and 4s, rewrite them. They put in scaffolded questions that led the students to the task because the students were not, they did not get response from the students that they had expected. Okay? So, changed questioning. They scaffolded in questioning. Now, that brings to my mind, if you scaffold in questioning, does the task remain a level 3 or 4 task? Okay? So that's just a lens to think about. Because quite often as teachers, if we have a really hard task, we start scaffolding questions in, and that changes the DOK level required for student performance. And that's what happens quite often. So the third lens is, that last lens is that, that student response or expectation. What do I expect? How do I expect students to respond to the task? So those are the three lenses we're going to take a quick look at. And I thought the best thing to do was model this for you. I actually did this in a 7th grade classroom. What you're going to see is a very short lesson that I did for about 15 minutes. And this, if you are a 6th or 7th or 8th grade teacher, this is part of your standards now. If you are a K-5 teacher, it used to be part of your standards, plotting points, function tables, starting in what, 4th grade, I believe? Okay? And you even plotted points earlier than that. Okay? But now, now it's primarily a 7th and 8th grade, 6th, 7th, and 8th grade standard. So here's what I want you to do. Just to turn and talk to your partner about what you see. Go ahead, take about 30 seconds. Okay, so what are possible coordinates for point A? Go ahead, talk to your partner about that. Okay, so I want to take some responses and see if, by the way, as you're doing this, if you take a look at kind of the questions we're going through, let's view this through this lens a little bit of DOK. Think about where we may be functioning as we go through this. Okay, so what are some possible coordinates? Who's got some?
You
Matt,
want me to raise
what did
your
you
hands?
come up with?
2, 4.
Okay, 2, 4. Who else came up with a possible coordinate?
3, 6.
1, 2.
Okay, we got a 1, 2. Okay,
X is
right
half
here.
of Y.
Positive, positive.
A positive, positive. Okay.
X is half of Y.
Ooh. X is. Any others? Any others?
Here, I got it, I got it, I got it.
We came up with they had to be positive numbers and that one is going to be greater than the other because of the distances.
Which question might be, so which one would be greater? That's a really good idea, isn't it? I mean, which one, as a teacher, then I would say, okay, wow, one is greater than the other. How did you know? And which one has to be greater? All right? All right, does someone have one more value for me, just one more coordinate pair?
I'm going to give a totally random one. 2,000 and 4,000.
4,000, awesome. Love that. Okay, now, I don't know if we can see up here. These are the ordered pairs.
Right there, Carol.
I'm up with. I want you to look at those. And I want you to I want you to see, what do you notice? Your partner about what you notice. Do you see any patterns, okay, based on the answers you gave me? Or another question I might ask is, what conjectures can you make based upon what my students in my classroom told me? And this is exactly what happened when I did in a 7th grade classroom. What conjectures? Yes.
The students are assuming that both the x and the y axes are going in the same increments.
Very nice, okay. Follow what you're saying? Okay. That they're the same increments. Okay. Very good. Okay. Do you notice a relationship between the x and the y? In fact, one group even called it out and said that x is smaller than y. One was very specific that they think that x is half of y. Okay? So, one of the things that is really, really going to be important is there's going to be a lot of open-ended questions like this in STARBAC, in SBAC, where students are going to be asked to identify their assumptions. So I want you to take about 30 seconds and talk with your partner about what assumptions we had to make to come up with those coordinates. We had one assumption, didn't we, that this assumes. How many people made the assumption, as I did when I designed this problem, that my intention was that students would view the scales, the x-axis and the y-axis, as the same scale, numbered the same way? How many people, when they looked at this, just made that assumption? Okay? Yeah, it's interesting. Doesn't have to be that way, does it? Were there any other assumptions that you made other than that?
We were working in a positive quadrant.
That's a positive quadrant. Quadrant 1, very good. Any others?
We made an assumption that it was numbers.
Made an assumption that these were numbers. Yep, absolutely.
Oh, over there.
I made the assumption that x is half of y.
Okay, so you were looking at this distance here and saying that represents the x value, and it was a half of y.
We didn't show him the laser.
Okay, very good.
That's okay. We're assuming that the intervals on the x and y axes are the same.
If I was a EL student and I couldn't read, then I might make the assumption that that was a point because it doesn't look like one to me. A circle with a void in it.
Okay, so we made the assumption that that's a point. Okay, all right, so here's my next question for you. I'm going to give you that's 0.46. And I give you a point B. Here's what I want you to do. Talk to your partner about what the coordinates for point B might be. Okay, again, take about 30 seconds. What do you think, and again, I need you to explain your reasoning. Defend why you think it's a possibility. So what do you think the coordinates of that might be?
Got one here.
We all said it was 8, 12, because you're doubling the x and then doubling the y.
Ooh, 8, 12. Now, doubling the x and doubling the y. Can anybody explain where she came up with that idea? What do you think she means by doubling the x and doubling the y?
Could be that's an equivalent fraction or equivalent ratio of plotted points. I mean, it could be 5 and 7.5 too, depending on where the marks are on. But I mean, scale-wise, 8 and 12 make more sense.
Okay. All right, but you think it has to do with could be equivalent ratios? Okay. Is that what you were thinking? over here? When you get, okay, equivalent ratios? All right. Any other possible reasons for why that could be 812?
We're doing this in our classes right now, and we were using Pythagorean's theorem and the distance formula to determine that point B.
Ah, okay. So you could use the Pythagorean theorem, and you could use the distance formula. And interesting, because what this class of 7th graders who hadn't yet had the distance formula said to me was they said this. They said it's 812 because if you take this length and double it, you get that length. Okay? Which is kind of a similar idea. Yes, Deb?
Well, in my class, that would mean that when they're slicing the pizza, they didn't make an error, so it's a straight line. So for the older grades, that would mean the same slope.
Be the same slope. Okay, so we could look at this from a slope perspective. So I've heard slope, I've heard distance formula, Pythagorean theorem. Okay, equal ratios. All right, now, how might you respond? Because here's what a kid said. Here's what a student said next. So a student actually said, I said, give me another point. And the student said 5.7. Okay? So how would you respond to that student? Talk to your partner right now. Student says, I think 5.7 is on that line. What would you say to that student? Okay, how might you respond? What would you say to this student that said 5.7? Or what might you say to the class?
I would ask them to prove it. So I would ask them to put the increments on the line and show that that is 4, 6, and 8, 12, and then locate 5, 7.
Okay, so you would actually ask them to prove it and maybe give them a strategy if they didn't have a strategy, which would be look at the increments, okay? But wow, if when you ask a student, think about this, where you are when you say prove that. Think about where that puts us on the DOK.
Okay, when I was thinking of this, I realized that what I was doing was I found a pattern. And I would ask them, I go, okay, look at the patterns between 4, 8, 6, 12. Does 5, 7 follow that pattern?
Okay, we're looking for a pattern. All right. Okay. How else? What else might you ask? What pattern do you see?
I would tell the student that I could see how they got that by adding 1 to the x and the y value. And then I would ask them to continue that trend and see if it follows to land on 8 and 12.
Ooh, okay. So asking them what pattern how did they move from 4, 6 to 5, 7, and if they respond, or if another student responds, you added 1. Okay, continue that pattern, and do we ever land on 8, 12? Excellent.
I would ask them to look at it in terms of fractions, and since you know that 4 and 6 are pairs and 8 and 12 are pairs, how did they get there?
Okay. All right, so 4 and 8 are pairs. So if I wrote the fraction, okay. Okay, so 4 over 6 is an equivalent ratio to 8 over 12. Okay. And so is 5 over 7 an equivalent ratio? Okay. What's really interesting, I had never seen this before in my teaching. I don't think most of us had. That in Common Core, proportionality in 7th and 8th grade is defined as a function where a linear function where the line goes through the where? The origin. I never saw that in my education, math education before. That is a whole new way of looking at proportionality. Okay? All right, so, Cammie, you had some questions.
And now she gave them to me, Mark.
Okay, all right, Deb.
So I'm going to Cammie was nice. Look at this whole page. You guys can verify there's a whole page of questions Mark just asked us. So I highlighted 5 of them. What I thought I'd do is have you do that prompt that's up there on the 5 questions I'll read you that Mark just asked us. So he's going to ask us to look at the DOK levels of some of the questions. So I'll remind you of 5 questions, and then you can talk to your partner about what DOK levels you think. All right? Okay, so here are 5 of the questions we were asked in the last 10 minutes or so. What could be a possible coordinate of point A? Explain your reasoning. Which one would be greater? How did you know and which is greater? What assumptions did we make to come up with these coordinates? Defend why it is a possibility. What do you think she means by, that was after someone's response. So those are 5 questions. You could think of other questions you may remember, and you can talk to a partner about DOK levels in the questioning that we were just undergoing.
We want to get you thinking of this through this lens of DOK levels. Task selection is really important. The questions you ask are obviously very, very important to make sure they're not too leading, not too scaffold, open-ended enough, but also that you respond to the student responses and you have some expectations. One of the things Tim Kainold says is, what do you think about when you're lesson planning? What are you going to say when the students get it? And what are you going to say when the students don't? Okay, that's really important in your lesson planning. You know, there was a couple things that you said today that I didn't expect. Okay, but many of them I did, because I did it in a classroom first. All right, so with that, we're turning it over to Fran.
Just for a moment. So I want to just reiterate, and we kind of did it yesterday with the group that came yesterday, but I'm going to turn into a broken record, which you may in your head say you already are, but I'm going to add some more things to that broken record script. And one is that the idea of thinking about the DOK levels, or heck, let's just call it Bloom's taxonomy. That's the other thing it is, okay? Is that the idea that this is value added to Go Math. It's not instead of. It's not a special time during the week. It's value added to Go Math. You have to ask questions anyway, so we're just saying pay attention to the levels of questions that you're asking and try to ask higher up in the DOK from time to time. Because your kids have to start thinking. Now, I mean, Jerry was paying attention to me all day with these groups of kids, and I don't know that I asked many recall questions because they were really good at recall. They could tell me step 1. They'd even answer recall when I didn't ask a recall question. So I asked the DOK 2-3 question, and they answered with a 1 answer. And it was like, no. I don't want to know that you multiply the numerators together. That's not what I asked. So you have to kind of be this good sleuth and keep at them because they are number crunchers. We are number crunchers, and we're all trying to change the course, okay, so that we become thinkers.
Good evening, everyone. I'm happy to be here. I get to be with you, which rocks. 2nd, 3rd grade, I actually, when I was a teacher in the classroom, I taught 2nd and 3rd grade. So that is your chance to think like this guy might actually have some street cred for 2nd and 3rd grade. Okay, let's hope so. All right, so I hope the first part was illuminating and wonderful for you. Let me orient you to the rest of our work for this evening. And as it was alluded to, we're looking at continuing with our work with student thinking and questioning to stimulate them in that endeavor. Let's see if I can get this right here. No. Here we go. Our work this afternoon. I hope you can read that, but I'm going to read some of it to you anyway. To orient you to our task, at the top, as a whole group, we will be going over a sample problem that I will provide for you in which to practice and take a look at our task that you will be doing both individually and with some friends and colleagues. But what that is going to look like is this. As you can see, we'll be asking some of these questions about student questioning. How do we get all kids thinking in math? Well, we do provide structures for them to interact. A lot of the work we've been doing on our PLCs, things like Think, Pair, Share, Show 3 Ways, and we have developed and enforced the expectations for them sharing, created a safe environment. So things like that are generally in place. We're going to ask questions about how do we get kids thinking in order to access a math task or a math problem. And the second one you can see is the same question nearly, except for instead of access, we're looking at questions to help them unlock the problem. So when we're looking at access, we're thinking about things like academic vocabulary. We're thinking about things like language forms. We're looking at things like formatting of the actual task itself within their text. And sometimes we need to really hone in on those things just to get our kiddos able to really even just access the task itself. So when we talk about unlocking a problem, how do we get them to unlock a problem? We're getting a little bit deeper. They've got the information to access. How do we help them grapple with that information, manipulate it, make a plan, do something with it in order to get closer to some sort of answer, process, something they can share, hopefully on the road to success, right? You see underneath there we have non-starters, misconceptions, students who have misconceptions, and kids who kind of got it, and we want to extend their thinking. So we'll be looking at a moment at some samples of what that might look like, and then you'll be continuing that work. Then, after we take a look at that sample, this is what you'll be doing. In mini PLC groups, and you can define that as you wish, but that's you and groups at your tables with your friends and colleagues. You'll be working with your curriculum, your program, looking at hot problems. Hot problems is up there. I don't want to box you in specifically to hot problems, so let yourself be a little more free if you wish. But the reason we have the hot problems up there is generally those are great fodder for deeper questioning. I think that's probably pretty self-evident, right? Okay. Then, with your groups and with your own thinking, you're gonna do the lion's share of the work. You're gonna be able to walk away with some questions that you can insert into your instructional design, and you'll physically insert those questions. You write them on a sticky note, stick it in your TE, and then hopefully you'll commit to yourself and maybe even a friend or a colleague, hey, you know what, I'm gonna try these out. I'm gonna use these in the lesson tomorrow or next week or whenever it may be. We'll have some time to work on that. That second to the last bullet about revising the questions. This will really be an important part of the process. I'm not going to direct you when to do that, but within the stream of your work, I'm going to really encourage you to, just like any form of writing, it's good to revise. And the lens that I'm going to encourage you to look with in your revisions is to look for leading questions. It's tough to do that, to craft a question that gives a kid enough direction to go without taking them there all the way. That takes some practice, and so that's what we're going to try to do. We will have some time to share. It's great to be in grade level groups. I know we have 2 grade levels, but that'll be perfect. We'll get to share, hear some of your colleagues' thoughts. You already know you always pick up ideas when listening to your colleagues. Fantastic process, I love that. As you can see, this is taken from grade 2, chapter 7, amounts greater than $1. 3rd grade, I love you. I taught 3rd grade. I always default to 3rd grade examples, so I just chose a 2nd grade example this time. It's not pertinent to the task, but I just want to let you know that I love you, third grade too, okay? So here is the problem as written in the Go Math manual. Pam has fewer than 9 coins. The coins have a total value of $1.15 and 15 cents. What coins could she have? There's a question mark after have. Draw the coins, then write a list of her coins. In a moment, I'm going to reveal my thinking on some of the questions that I thought of through no magical means at all, just by being like you and thinking about it. But before I do that, I'd like you to consider this and just right off the top, thinking about especially the focus of accessing that problem, vocabulary, language demands, format demands, and unlocking that problem, anything deeper. Just informally chat a little bit about some of the things that you might consider either might be sort of common errors that kids might make that you would want to address through questioning, or just any questions that you might anticipate you might need to ask your students. So just take a minute and do that, please. Thank you. And because the camera loves you, I'd like to take this opportunity to hear from some of you just your thoughts about this task, the student thinking that might be going on, and the types of things you might want to bring to the table for them in order to help them figure this thing out. So let's have some volunteers. Karen Torres, thank you so much. I appreciate it. It's good to have friends.
We talked about the fact that students would need to understand what fewer than 9 means.
Thank you, Ms. Torres. Fewer than, especially, yeah, I think so. A little language demand. Thanks, Jerry.
So just asking the kids, how many coins could you have out there? Fewer than 9, they could have 8, 7, 6.
Great. Let's hear from some others, please.
What coins could we use and what are their values?
Maybe what's an easy way to represent a coin? What would be an easy way to draw a coin? Because I'm afraid they're going to be drawing little heads on circles.
And school lets out at 2:25. Yeah, right. Thanks, Tracy.
We also talked about fewer, what's fewer than 9, and also total value. What does that mean?
Thank you, Mr. Candidi.
We talked about them having to do 2 tasks, draw and a list. A lot of them will just do one.
Okay, wonderful. Absolutely wonderful. Anyone else? I know there's a lot out there for sure. Anyone else care to share something? Okay, so, we're ready for the big reveal. A window into the mind of a former 2nd and 3rd grade teacher, now a math coach. I did not spend all evening doing this like when we come and demo in your classrooms and we have like 6 hours to prepare. No, this is just right off the top of my head. And so, you know what? Some of these I have not revised yet. So perhaps I'll do some revision too. These are just things we were talking about, thinking about, and I already heard some people with a similar thinking, which is I love the power of collegial work. So let's just take a look at some of the things that I was thinking about, which you can either agree, disagree, change, whatever. But, okay, if you remember, we kind of had our 3 categories, if you will, and not necessarily that these are mutually exclusive, nor would the questions necessarily only belong in one category, but I use this sort of frame to start thinking about, like, imagining myself with the kids and this task, right? So, as you can see, for the kids who might be just non-starters, like, I'm not even accessing this, Mr. Kolb. What's going on? So, some of the basic questions that not necessarily even pertinent to this specific task, but questions that we can ask for problem solving in general. What is the question asking? Directing them to, even just understanding the task. What do you need to find? Read the first sentence aloud again, not a question, but a direction. Can you draw a visual? What coin could you start with? And perhaps ask why. For the kids that are perhaps starting and they might be not quite sure where on the road they want to go next, or perhaps have a few misconceptions. We could look at things like information from the problem. What do you need to use? Redirect to what is the most coins she could have. What numbers did you read in that sentence? Remember, this is a second grade task, right? Are there words or ideas that you don't understand? How can you draw a coin? And then for the kids who got it, or are maybe those who we might want to encourage to extend their thinking, things like, is there only one correct answer? And my favorite one of all, how do you know? I mean, that's like the one Common Core question that is, it's a beautiful thing. What is the least number of coins you could use? That'd be kind of fun. And then I'm particularly proud of this question, I have to say. How would your answer change if the total value was doubled? So we've got one task. We know that the right answer is important, but it's not the end-all, be-all. That's not what we're about with Common Core, right? And so especially for those extended thinking questions, those are the kind of things we might want to consider. Okay, so that's the sample. Thank you for your thinking and sharing. Thank you for being so polite and looking at my thinking. And so now you get to play and talk and work with your colleagues and friends. I'll put the directions up here again, and we're going to pass out some materials to you. But the basic idea is this. It's very simple, and there's power in simplicity often. You get a chance to get into your TEs and look for your lessons, through your lessons, looking for those opportunities in which you may want to consider different types of questions that you could ask your students. We're going to provide you with some stickies to put them in there, and I think the other document has already been passed out, and then I'm going to let you rock and roll on that. I will bring you back together to do some sharing in about, Jerry, what do you think? We want to do about maybe 25, 30 minutes? Let's do at least 30 minutes. So you know what that means when you hear that? It's not like, oh, I just have to do this thing. This is like we're giving you time to be thoughtful and working. Thank you.
What I find with the whiteboards is that we're getting 6 and 7 ways instead of 3 ways.
Well, I think it's really important too, when you've got your non-starters, you definitely have to start with something that they can physically see. You can't just look at the words and say you've got it and extend it.
True.
So you've got to have something that they can manipulate or something they can draw.
Right.
Well, if we do the compare, we can have the manipulatives that are the bar, and then also the ones that are the pie.
So you're combining
circle.
So the different circle, yeah.
Right. It's a pie.
And I think that once we go from non-starters and we go to those with misconceptions, I think it's really important to look at this as we just did and say, some kids are going to say, well, this already is 2/4.
Right.
Because maybe they haven't yet, although they're a starter, they have a misconception of the shaded parts.
Yeah. And then we have to go back to what a numerator and a denominator is, and that the denominator is all parts together.
And then be really aware as the educator that we're using the vocabulary consistently, and not just from this chapter. They need to hear the consistent vocabulary from all the chapters.
Right.
Well, and like you said earlier about the repeating again, what is the numerator, what is the denominator, having them start out with how many parts in all.
Right.
And going from there.
Right.
So once we've got some of that misconception down, what is a good question that we could ask for our got it extend?
How many ways can you represent this fraction?
Okay.
In a picture.
All right.
Or it doesn't even have to be a picture if they can think of another
Would you
way.
at that point introduce equivalent, or the vocabulary of equivalent fractions, even though that doesn't come till chapter 9? That might be a good pre-teach,
I
so
might
that
be
they at least
saying
heard it.
Right.
Yeah, I wouldn't teach it, but
Right.
if they would hear the vocabulary and be exposed to it already.
Right. And definitely go back to another way because they were taught another way. So I would reuse, is there another way to write this fraction? And see if they can get that from the previous lessons. And then also talk about those are equivalent fractions. Yeah, I think that would be a good idea.
Really getting it, they need to go push ahead and say,
They do.
Here's equivalent. What you just did is an equivalent fraction.
Right.
That means we're going to get into it, but that's what this is.
And they know what
equal. They
Right.
can figure that out. Yes.
Right.
I think, though, we need to really be careful because some of our EL students, they get lost in the woodwork. They're quiet, they don't want to speak out, and you don't always know what they're understanding. So I think it's really important that we constantly go back to our math journals, go back to our walls that have, and make sure that they're accessing what is available in vocabulary.
Yes.
Because if they don't have it and you ask them what's the error, they're not going to get it.
Right. I think we're training ourselves with the vocabulary constantly so that we can use it more.
I agree.
And
Well,
use.
We have quite a diverse population, and they're transient too. And so
Right.
I just got a new student this week. He hasn't had any of this.
Right.
So we're starting kind of at the beginning with him, and I have to keep remembering that as we're going along.
Right. Do students help each other in your class?
Absolutely.
Good. So they can support the new student.
I have them in groups, and I have them paired to where there's always a strength and a weakness by each other. And so they do. We get heads together, bums up. I don't say butts. Heads together, bums up. And then I pull sticks, and whatever number I pull, because the students all have numbers, that student has to answer the question.
Right.
And they represent their entire group.
Right.
So my students are very engaged to make sure the student that can't speak English well knows what to say, because everyone gets a ticket. We have raffles at the end of the week, so they want you to represent well.
Right. So they listen to each other and they make sure. I like that.
It's really important to stay engaged.
That's good. So, another way to write a fraction, and then the last question we were talking about, use your Chapter 8 vocabulary words to explain your answer.
Absolutely.
Especially for our higher end kids.
And I think that just saying use your Chapter 8 is wonderful, but we might need to bring it down a level and actually tell some of the others who kind of have it but aren't quite there.
Right.
Take out your math journal. If they
Exactly.
haven't opened it yet,
Always.
remind them.
Right.
Use your math journal. Use the charts on the wall. What can you tell me?
Right.
Or can you point to it on the wall?
Right. And they can even collaborate on this answer before they share, like you mentioned.
All right, so what is the basic question? It's
So we could prompt them right away.
how much will each friend get?
Yeah. The whole pie, though, we need to make sure that they're still.
Okay.
Oh, so that's a misconception one, right? Here.
So that's that operations question.
Okay, so each friend get of the whole
Or
pie.
even drawing. They can draw them out and group them into
Okay.
thirds.
All right. And then what are some ways that they can start to solve this problem? So,
9.3, measure with a centimeter ruler. And the hot question, the crayon was on the table next to the centimeter ruler. The left edge of the crayon was not lined up with the 0 mark on the ruler. What is the length of the crayon? Explain how you find your answer. I love these because they have a really hard time getting to that explanation of why after they solve them. So, some non-starters probably have a problem with where the crayon is. Why would go all the way to 11, right? Instead of where it needs to be. So just maybe asking them where is the crayon located?
Which first hand out centimeter rulers, so they have a little centimeter ruler in front of them. Do you think that would be necessary?
Maybe for the non-starters having a hard time understanding the visual. What are we trying to find? Which is the question. What is the length of the crayon?
And what is it we already know? Where does the crayon start? Where does it end?
And put it against that next line. And then what would you do? How would you
What strategy would you use?
Yes,
to
what strategy
solve?
would you use? Could you look at this just like a number line?
Do that, yeah.
Where it puts at.
Strategy.
That's great. You make a comparison to the number line.
Do you do that a lot with money and, yeah, all the time?
Number line.
Time.
I have 4 number lines in my room.
Oh, you do?
You received this document. You've probably already scanned it. If you haven't yet, it's simple. This is another tool for you to think about your own thinking. Here's an example I thought of. When I was in the classroom and a student got an answer that was clearly wrong, and it'd be like, oh yeah, good try. Almost. Some of those things that sometimes we do to either enable or, I'm not even sure of the word, but this is what I'm thinking about. You're professionals, and we want to take kids to where they need to go with their learning. We don't want to lead them there completely, but we want to ask them questions to help them get there, being kind, but also sincere and honest with them. Consider that when you are thinking about this document. This is for you to fill out something quickly, something that you are probably going to stop doing maybe, something you want to refine and change, or something you want to continue and deepen. Jot something down, keep it. You're going to bring it back next time. Put it on your desk maybe at school. Something comes into your head, jot it down. It's a reflection piece for you that we are going to have you bring back.